A. So we've got to solve this inequality, x squared greater than or equal to 4x plus 5. First thing to do is to bring everything onto one side. So x squared, take away 4x from both sides, take away 5 from both sides, leaves us with 0 on the right. Now, this is a quadratic, and what we're going to have to do is to write it as an equation equal to 0, and that will enable us to find what we call the critical values. Those are the values of x for which the expression is actually equal to 0. And this factorises quite nicely. To get minus 5, we've got to do either minus 5 and plus 1 or minus 1 and plus 5, but because we've got the minus 4 there in the middle, it's going to have to be minus 5 and plus 1, and it works now. X squared minus 5x plus x gives us the minus 4x. Now that means the critical values are going to be x equals minus 1 or x equals 5. So our inequality for x, the values which x can have, are going to have minus 1 and 5 in them, but which way do the inequalities go? Well, the way to do it is to think about what the graph of x squared minus 4x minus 5 will look like. So if I do a little sketch of the graph, because we've got the critical values, that tells us that when x is 5, it crosses over the x-axis, and also when x is minus 1, it crosses over the x-axis. So if I draw a sketch of the curve, it's a positive x squared, so it's a smiley face, and it's going to look something like that. Okay, but we want it to be greater than or equal to 0. So where is the curve greater than or equal to 0? Well, it's this part of the curve here and this part of the curve here. So this bit in the middle we don't want, because in this bit in the middle where the curve goes below the x-axis, our expression is going to be negative, and we want it to be either 0 or positive. So that tells us that our final answer is that x has got to be greater than or equal to 5, because we can have it equal to 0, and the other possibility is that x can be less than or equal to minus 1, and those are our answers for part A. Now, part B, it gives us an expression there. Well, it gives us an equation, 25x squared plus, doesn't give us a number, it calls it b, x plus 16 equals 0. And we want it to have no real roots, or in other words, we want it to have no possible solutions. So if we were to try and draw a graph of this function, then the graph would be sort of hovering above the x-axis, never actually crossing the x-axis, so that it would never actually be equal to 0, because the equation, we want to have no real roots. Now remember that if the equation were to have roots, then we'd be able to find them by using the quadratic formula. Now remember that in general, a quadratic we can write like this. Okay, so this is a general quadratic, and the quadratic formula tells us that the value of x will be equal to this. Okay, all over 2a. But this thing in the bracket here, we actually give this a special name, and this here, b squared minus 4ac, we call the discriminant. And the reason it's important is because if this is equal to 0, then there's nothing to add or take away, so we only have one root. That's when the curve just touches the x-axis. If b squared minus 4ac is a positive number that we can take the square root of, then by adding we get one solution, and by subtracting we get the other solution. There will be two roots. However, if b squared minus 4ac is negative, we can't take the square root of a negative number, so that means there will be no real roots, and that's what we want in this case. So what we're going to have to do is work out the value of b squared minus 4ac, and then say that that is going to have to be less than 0, and that's going to be our condition for the equation to have no real roots. Now b is the b that's in our equation here that we're trying to find, and then minus 4. Now a here is 25 and c is 16, and that has got to be less than 0, so that's the inequality which we've got to try and solve. Okay, so I can say, right, b squared minus 25 times 4 is 100, 16 times 100 is 1600, is less than 0. So in other words, b squared has got to be less than 1600. And now, like in part A, we find the values which b can have by thinking about, we can think about what the graph will look like if we try and draw a graph of b squared minus 1600. So we can do it like this. So draw my graph here. Okay, and then we say, I'll go back to looking at b squared minus 1600. So, and that's b squared minus 1600. Right, the graph, we know the critical values are when b squared is equal to 1600. So the critical values will be b squared equals 1600. So b will equal plus or minus 40. Okay, so the graph is going to look like this: plus 40, minus 40, and when I draw it, it's going to look something like that. Now we want it to be less than 0, so the area that we want is this bit here in the middle of the graph, and that gives us our final answer that we want b to be between minus 40 and plus 40. Any of those values for b will mean that b squared minus 1600 is less than 0, in which case the condition for the discriminant to be less than 0 is fulfilled, and the equation will have no real roots. Notice that we don't want it to be equal to minus 40 or plus 40. If it were equal to minus 40 or plus 40, in those two cases there would be exactly one real root. The graph would be just, the graph of our quadratic would be this 25x squared plus bx plus 16 will be just resting on the x-axis, but we want it to have no real roots. We want it to be hovering above the x-axis, and for that to happen, b has got to be between but not including minus 40 and plus 40.